everyone. We are doing number system part 2 and this is the third class of factor. My name is Ravi Prakash. Okay. So this is in continuation with factors 2. So we did 3 questions in factors 2. This is the fourth one. Okay. So how many factors of 3600 are divisible by 15, right? So in last video we discussed this concept, right? So we can do this question now. How many factors of 3600 are divisible by 15, right? So we first write 15 into its prime basis, right? What is 15 now? So 15 is nothing but 3 into 5, right? So 15 is 3 into 5, 3 raised to 1 into 5 raised to 1, okay. So while again picking the brackets from each term, right? So if I pick brackets from each term, so for a number to be divisible by 15, it has to contain at least 1 3 and at least 1 5, right? So from 3's bracket, I can't pick 3 raised to 0. From 5's bracket, I can't pick 5 raised to 0. And from 2's bracket, I can pick all the terms, right? From 2's bracket, I can pick all the terms, right? So, how many terms are here now? So, 2's bracket contains 5 terms. 3's bracket contains 2 terms. And here also 2 terms, right? So, 5 into 2 into 2. Total 20 such factors are there which are divisible by 15, right? So 3600 contains how many factors total? 5 into 3 into 3. So it contains total 45 factors. So out of 45 factors, 20 factors are divisible by 15, right? So 15 is 3 into 5. It has to contain 1 3 and 1 5. Every factor has to contain 1 3 and 1 5. So 1 3 and 1 for 1 3 and 1 5 from 3's bracket, I can't pick 3 raised to 0. From 5 bracket, I can't pick 5 raised to 0. Correct. Now again method 2. Method 2. We discussed in last videos also. Method 2, directly we can do it. So method 2 is, for a number to be divisible by 15, it has to be of the form 15k. It has to be of the form 15k, right? Now what is 15k? A number of the form a number which is a multiple of 15, right? So if 3600 is written as 2 raised to 4 into 3 square into 5 square, so the factors has to be multiple of 15. So what I'll do, I'll take 15 as common, right? If I take 15 as common, 15 means what? 15 actually means 3 into 5. So 15 means nothing but 3 into 5, right? So after putting 15 as 3 into 5 as common, what did you get inside the bracket? 2 raised to 4 into 3 into 5 raised to 1 raised to 1, right? That means this is my 15 and this is my k, right? So number has to be of the form 15k, right? So every factor inside this bracket will be multiple of 15 because outside I have already taken 15 common. So 15 into anything is a multiple of 15, right? So how many factors are inside the bracket? So inside the bracket, how many factors are there? You can see it. 5, 4 plus 1, 5, 1 plus 1, 2, and 1 plus 1 2. So 5 into 2 into 2, 20 factors. So 20 is the answer, right? Same thing we got here also 20, right? So method 2 is what we should use for all this kind of question. 15k, so take 15 as common, right? Okay, next question. We'll quickly do. You have to solve it, right? So next question. Okay, so next slide is, how many factors of 3600 are divisible by 40? Question number 5, right? So think mentally. Quickly we'll do this question. Divisible by 40 means what? Break 40 into prime basis. What is 40? 8 into 5. What is 8 into 5? 2 cube into 5. Okay, so 40 is nothing but 2 cube into 5, right? So if 40 is 2 cube into 5, so for a number to be divisible by 40, what I should do? I'll directly do method 2 now, right? We don't need to discuss method 1. We'll do method 2 now. So in method 2, directly I can write like 3600 was of the form 2 raised to 4. We don't need all this now. We can directly do method 2 now. Okay. So 3600 is of the form is 2 raised to 4 into 3 square into 5 square. Okay. So for number to be divisible by 40, it has to be of the form 40k, right? So I'll take 40 as common. 40 as common means I'll take 2 cube into 5 as common, right? So what is left inside? 2 raised to 1 into 3 square into 5 raised to 1, right? This is left inside. So this is my 40 and this is my k. So again the logic is same. All the factors of k when multiplied by 40 will become of the form 40k, right? So all the factors of k when multiplied by 40 will be divisible by 40, right? So how many factors of k are there? That means how many factors are there inside this bracket? So I need all the factors inside this bracket, right? How many factors inside this bracket now? Simply I can do 2 raised to 1. So 1 plus 1 is 2, 2 plus 1 is 3, and 1 plus 1 is 2. So 2 into 3 into total 12 factors are there. So 12 factors are there inside the bracket. So 12 is my answer for this question, right? This should be pretty clear now, right? Very good. So this is a good concept. We can do any such kind of question with this method, right? Let's move to question 6 now. Let's move to question 6. Next slide. Okay, so next question is, how many factors of 3600 are perfect squares, right? So how many are perfect squares here? So what is perfect square? So perfect square basically means that any natural number, right? If you take the square root, its square root will be an integer. That is a perfect square, right? For that, any natural number has to be of the form a raised to 2k. That means a number's power should be even. Power should be even. So if power is even, in that case, a raised to 2k. If I take the square root of a raised to 2k, right? That means square root means what? Power is half. So this 2 and 2 will cancel. So we are left with a raised to k, which is an integer. Right? This is what we wanted, right? What is the perfect square? So if we square root a number, its square root will be an integer. That is the perfect square, right? So all the perfect square has to be of the form what? A raised to 2k. That means a natural number raised to an even power. Natural number raised to an even power, right? So let's look at the case of 3600 now. So in case of 3600, okay, what is 3600? Again we should write. It is nothing but 2 raised to 4 into 3 square into 5 square, correct? Now again how many terms here? So 2 raised to 0, 2 raised to 1, 2 square, 2 cube, 2 raised to 4. There are 5 terms here. How many terms here? 3 terms. 3 raised to 0, 3 raised to 1, and 3 raised to 2. 3 terms here. And again 3 terms here also. Right. So first we'll discuss method 1, and again method 2 as a shortcut of it, right? So what is the method 1? Simple. I have to pick all the numbers with the even power, right? I have to pick all the numbers with the even powers. So what I should do? From 2's bracket, I should only pick 2 raised to 0, 2 square, and 2 raised to 4, right? I have to pick 2 raised to 0 also, because 2 raised to 0 into 3 raised to 0 into 5 raised to 0 will give me 1. And 1 is a perfect square. 1 is a perfect square as well as perfect cube. 1 is a perfect square as well as perfect cube, right? So I have to pick this 0, 0. So from first bracket I can pick these 3 terms. I can't pick these 2 terms, right? 1 and 3 are having odd power, will not give me perfect square. Now from second bracket I can again pick 3 to 0 and 3 to 3 square, right? I can't pick 3 to 1, again odd power. From third bracket also I can pick 5 to 0 and 5 square. I can't pick 5 to 1, odd power, right? So how many terms I got here? From first bracket there are 3 terms. From second bracket there are 2 terms. From here are 2 terms. 3 into 2 into 2. Total 12 factors are there, right? 12 is the answer. 12 factors are there which are perfect square. In 3600, out of total 45 factors, there are 12 factors which are perfect square, right? Now I can write what are those factors. I can write now by multiplying, okay? 2 raised to 0 into 3 raised to 0 into 5 raised to 0. So 1 into 1 into 1 will give me 1. 2 raised to 0 into 3 square, that is 1 into 9 into 1 will give me again 9. Now 2 raised to 0 into 3 square into 5 square. So 1 into 9 into 25 will give me 225. Right. Similarly, suppose 2 square, 4 into 3 square 9, 4 into 9 36, into 5 square, 25. So 36 into 25 is also perfect square, right? That is what, 900. So like this I can write all those 12 factors, right? How many terms? Again 3 terms here, 2 terms here, and 2 terms here. So 3 into 2 into 2 equal to how many factors? 12 factors, right? So there are 12 factors of 3600 which are perfect square. Correct? Now method 2. Method 2. We'll discuss method 2. Okay. So method 2. Now method 2 is a very easier one, right? Shorter one I should say. What I should do is if 3600 is 2 raised to 4. So this what I should do simply divide 4 by 2, that is power, 4 is the power, 4 by 2 plus 1, right? Divide, I'll tell the logic behind it, right? Divide, this power is 2 here, simply divide 2 by 2 plus 1. Power is again 2 here, simply divide 2 by 2 plus 1. Now, what is the logic behind it, right? What does it mean? This actually means that, 4 by 2, while writing 4 by 2, that means that from power 1 to 4, how many are multiples of 2, right? So suppose we had written 2 raised to 0 here, right? We had written 2, let me write here. We had written powers of 2, right? So what are powers of 2? So powers of 2 here, factors of 2 raised to 4, powers of 2, 2 raised to 0, 2, 1, 2 square, 2 cube, 2 raised to 4. So 4 by 2 here means out of the 4 terms, how many are multiples of 2? Simply divide by 2, right? There are 2 multiples. So 4 by 2 will give me 2. There are 2 multiples, right? And plus 1. Plus 1 because of this 0. Plus 1 because of 0, right? So I want to add this plus 1. So simply do 4 by 2 plus 1. 4 by 2 plus 1 is how much? Is 3. So 3 is here. Correct. Now you can ask me that what if I have 2 raised to 5 here? In that case, what I need to do? Right, so nothing. You write 5 by 2 in that case, 5 by 2 plus 1 only, right? Just ignore the decimal part, right? In this method, actually what we need to do, we need to ignore the decimal part, right? Why? Because you can think that even if there are 5 terms here, how many even powers from 1 to 5? Only there are 2 and 4, right? That decimal part won't make any impact, right? So simply 5 by 2 plus 1 I can do. And I can write 5 by 2 as 2.5. So 2.5 is what? Ignoring decimal part, we are left with 2 only. So 2 plus 1 I should take it as 3. So 5 by 2 plus 1 I should take it as 3. Right? So just ignore the decimal part. We'll do in next question, right? This one again. So right now, out of these numbers, right? So out of these numbers, 4 by 2 plus 1, 3. Okay. So 4 by 2 plus 1 is 3 into 2 by 2 plus 1. So 1 by 1 plus 1 is 2 and 1 plus 1 is again 2. So 3 into 2 into 2, 12 factors. This was the answer, right? Last slide also, this was the answer only. That how many factors of 3600 are perfect squares? 12 factors, right? This logic will work everywhere because what we are doing is ultimately out of these 4 factors, right? What we are doing is how many are multiple of 2? That is 4 by 2. Out of this total 5 factors, what I need to do? Take from 1 to 4. So 1 to 4 there are 4 factors, right? 4 numbers. How many multiple of 2? 4 by 2. Why plus 1? Plus 1 because of the 0. I had to add this always. I had to add this 2 raised to 0, right? In 3's bracket also. In 3's bracket, 3 raised to 0, 3, 1 and 3 square. So 2 by 2 means from 1 to 3 square, 3, 1 and 3 square, there are 2 terms. So out of 2 terms, how many are multiple of 2? 2 by 2. That is 1. And 1. And why is plus 1? Plus 1 because of this 2 raised to 0. Right. There are 2 terms here. This is the logic behind it, right? So you can easily do such kind of question. Okay. Let's make a bigger, let me write a bigger question here, bigger number. How many factors of 2 raised to, let's say 19 into 3 raised to 15 into 5 raised to 10 are perfect squares, right? So how many factors of this big number are perfect square, right? Very simple. What you do? Simply divide power by 2 and add plus 1, right? Simply divide power by 2 and add plus 1. Simply divide power by 2, add plus 1. If there are decimal part, if there are, right, any decimal part, simply ignore decimal part. Simply ignore decimal part, right? So what you mean here? What you mean? What I mean here is 19 by 2 is what? 9.5. So 9.5 I'll take it as 9. 9 plus 1 is 10. 15 by 2 is what? 7.5. I'll take it as 7. Ignore decimal part. 7 plus 1, 8. 10 by 2 is 5. 5 plus 1 is what? 6. 5 plus 1 is 6. So 10 into 8 into 6. How much? 480. That's it. 480 is the answer. Right. So for this big number, 2 raised to 19 into 3 raised to 15 into 5 raised to 10, only there are 480 factors which are multiple of, sorry, not multiple of, which are perfect squares, right? Logic again clear, because 2 raised to 19 is here, that means 2 raised to 0, 2 raised to 1, 2 is square. I will write till 2 raised to 19. So first 19 by 2 means here 1 to 19. How many are multiples of 2? Because for perfect square, I only have to take multiples of 2. So 19 by 2 means there are 9 multiples. If we count here, there are 9 multiples of 2, right? That is why I meant by ignoring decimal part. 19 by 2 is 9.5. Ignore decimal point 9. Right, decimal part 9. So 9, there are 9 numbers from here to here, which are even power. And then add plus 1 for this 2 raised to 0. So add plus 1. Right, this is the logic behind it, right? So I hope this is clear. So any bigger number, at maximum 10 seconds it will take to find the number of factors which are perfect square, right? Okay, next question. We'll go to next slide. Okay, so next question is, how many factors of 3600 are perfect cubes, right? Now what is perfect cubes now? So perfect cubes are any natural number raised to a power which is a multiple of 3. That is a raised to 3k form, right? This is a perfect cube. Why? Because in a perfect cube, if you take the cube root, right? Cube root means power is 1 by 3. So 1 by 3 get cancelled. So you'll be left with a raised to k, which is an integer, right? Which is an integer. So a perfect cube means if we take the cube root of that number, the result will be an integer. This is what a perfect cube means, right? For example, 5 raised to 6 is a perfect cube. Why? Because 5 raised to 6, if you take the cube root of it, what is the result here? 3 will cancel 2 times. So 5 is square. That means 25. So cube root of 5 raised to 6 is what? 25, right? So this is an integer, right? So 5 raised to 6 is a perfect cube, correct? Now, so how many factors of 3600 are perfect cubes, right? So for perfect cube, again we can write in same funda. Okay, move to next slide. Okay, so how many factors of 3600 are perfect cubes, right? So perfect cubes means all the natural numbers raised to a power which is a multiple of 3, right? So I should pick only those numbers which are a multiple of 3. So like in 2's bracket, which numbers I can pick? I can only multiple of 3 is here is 2 cube, right? And I should always pick 2 raised to 0 also, because 1 is a perfect square as well as perfect cube. Okay, so from first bracket I can only pick 2 terms. From next bracket I can pick only 1 term, because only 3 raised to 0 I can pick, no other are multiple of 2 here, right? So only 1 term. From third bracket also I can pick only 1 term, because there no other multiple of 3 exist. In second bracket also no other multiple of 3 exists, right? Perfect cube means all the natural numbers raised to power of 3. Power of 3 means any multiple of 3 I can take, right? So 2 into 1 into 2, sorry, 1. So total there are 2 factors. So only 2 factors are there of 3600 which are perfect cubes, right? So which are perfect cubes. So I can write all those 2 factors. I can write both the factors here, right? What is the number? 2 raised to 0 into 3 raised to 0 into 5 raised to 0. So 1 into 1 into 1 will be 1. 1 is such factor of 3600 which is a perfect cube. Second, 8. 8 into 1 into 1, again 8. So 1 and 8, right? So 1 and 8 are the only 2 factors of 3600 which are perfect cube, correct? Yeah, I hope this is clear. Now again method 2. Method 2 I can directly do. Again, same funda I'll do, right? What we did in perfect square. So in perfect square, we divided by 2 and plus 1, because dividing by 2 means how many multiples of 2 are there, and plus 1 means for the 0 part, right? So same funda I can do here also, method 2. So in method 2 I can write simply power is here 4. So for perfect square dividing by 2, for perfect cube dividing by 3, because we are searching for multiples of 3. So simply power divided by 3 plus 1, right? Here also 2. So power is 2, 2 by 3 plus 1. Here also power is 2. So 2 by 3 plus 1. Correct. Now again same funda. In method 2, what in this funda, what we do? We always ignore the decimal part. I'll tell you why. Ignore decimal part. Right? Because same funda as last slide for perfect squares, that if you're finding multiples of 3, this 4 by 3 means, what does this 4 by 3? Only this 4 by 3, no, not plus 1. This 4 by 3 means from 2 raised to 1 to 2 raised to 4. Out of these 4 terms, how many are multiple of 3? So only one term, right? So 4 by 3 is what? 1 point something. So ignore decimal part. So I'll get only one term. And y plus 1 because of this 0. I have to include 0 also, right? Power 0. That is why. So 1 plus 1 is 2 here. Right? So only 2 terms are yet. So 4 by 3 means out of 4 terms, how many are multiple of 3? Simply 4 by 3 we will do. Plus 1. Plus 1 I add for what? 0. Simply again 2 by 3. What is 2 by 3? 0 point something. So ignoring decimal part will give me 0. 0 plus 1 is what? 1. 0 plus 1 is 1. 1. Right? So 2 by 3 again means what? Out of these two numbers, 3 is 1 and 3. 2, how many are multiple of 3? No, none of the numbers, right? So 2 by 3 means 0 point something, ignoring decimal part. There is a logic behind it, right? And one term I have to add because of the 0, right? So simply I can do again here also 0 point something, ignore decimal part, 0, 0 plus 1 is 1. So 2 into 1 into 1 is, so 2 is the answer here. 2 is the answer, right? So we got 2 here. Fine. So how many for perfect cube? Simply divide by 3, power divide by 3, add plus 1, right? Add plus 1 and ignore decimal part. Okay, so again we'll do a big question here, a big number we'll take and we can solve it. Okay, how many factors of 2 raised to 19 into 3 raised to 17 into 5 raised to 12 are perfect cubes? Right, so this looks like a tough question because the numbers are big, but if you go with the logic in second method, very easy, right? What we'll do, simply power divided by 3 plus 1, here also power divided by 3 plus 1, power divided by 3 plus 1, correct? So we'll only pick up those numbers which are power divided by 3 plus 1, right? And also ignore the decimal part, right? Ignore decimal part. I told you logic, right? Why? So very simple now. It's very simple, right? What is the answer? 19 by 3 is what? 3, 6, 18. So 6 point something. Ignore decimal part. Take 6. 6 plus 1, 7. 17 by 3 is what? 5 point something. Take 5. Ignore decimal part. 5 plus 1 is what? 6. Sorry. Take 6. So 7 into 6. Okay. Now 12 by 3 is what? 4. 4 plus 1 is what? 5. 7 into 6 into 5. This is the answer. 7 into 6 into 5. 42 into 5, 210. So 210 is the answer, 210 factors. So for this big number, 2 raised to 19 into 3 raised to 17 into 5 raised to 12, total 210 factors are there which are perfect cube, right? So very important, these two videos, factors 2 and factors 3. We have done lots of good concepts and good questions. Okay, so in the next factors 4 video, we'll be taking to another higher level, right? So we'll discuss all the concept of factors in this some 7-8 videos. We'll follow very strictly these videos, right? You'll not get a single question in CAT outside these concepts. That's my written guarantee to you. Okay, bye. See you in next video.